Hi everyone. We are going to see about deadlock prevention and avoidance in today's session. Already we have seen what is a deadlock and what are the characteristics of deadlock and what are the conditions for occurrence of deadlock, and we have seen what is resource allocation graph, and from the graph how we can prevent the occurrence of deadlock and what are the states of occurrence of deadlock from the graph. If cycle is getting formed, there is an occurrence of deadlock, and if the graph is of cycle free, then there is no occurrence of deadlock. These are the things which we have seen on the earlier session, and today we are going to see about deadlock prevention. Deadlock prevention is nothing but we have already seen what are the characteristics and conditions of occurrence of deadlock. If there are four conditions, which is of mutual exclusion, hold and wait, no preemption, and circular wait. If any of this condition has occurred, then the deadlock will occur on that system. This is the conclusion we have said earlier. For deadlock prevention, if we prevent the occurrence of these four conditions in a system, then let us say that the system is safe and it is deadlock free. That is the deadlock prevention method which we are going to discuss further. The deadlock prevention consists of four necessary conditions. Okay, we have to ensure at least one of the conditions can't hold. We can prevent the occurrence of deadlock. Okay, in this, the first condition is nothing but mutual exclusion. In this, as we have discussed earlier, mutual exclusion is nothing but when a resource is getting allocated for a process, other than that process, that resource can't be allocated for another process simultaneously. This is the condition of mutual exclusion. In this, for excluding this condition, we are taking a scenario in which the resource which is requested and which could be in a shareable mode, and when it is on read only files, it is not required to be mutually excluded. That is, the shareable files might be shared mutually. That is the scenario of mutual exclusion. In the situation, if a reading file is getting hold by a process and another upcoming process is requesting for another read on that resource, then simultaneously the read access for the new process can also get allocated. In this situation, the deadlock occurrence due to mutual exclusion will be avoided. And another one thing is, in this, it must hold for non-shareable resources also. That is, the read-only files, whether it is shareable or non-shareable, it can be allocated simultaneously for more than one process. And the second condition is nothing but hold and wait. In this, what is hold and wait? We have already seen hold and wait is nothing but it must guarantee whenever a process requests for a resource, it should not hold any other resource previously. For example, if a process is requesting for 10 resources, if it say that process is continuously request for the resource and holding it, and it is getting preventing the resource getting allocated for other processes, then all the resources will get stacked on that same process itself. This is an worst case for allocation of the resources in a system. So we must avoid that hold and wait. So before allocating resources to a process, each time the system will ensure no other previous requested resources are being held by that process already. After that only the resources will get allocated. The required process to request and be allocated all its resources before being execution, or allow process to request resource only when the process has none allocated to it. This is the situation. That is, Either the process should not hold any resources, or the previously allocated resources must be freed from that process. Then only the new requested resources can be allocated for that process. Then low resource utilization, that is nothing but in the situation previously which we have discussed, if a single process is holding more number of resources, high resources are being holded by an process, so which is getting unavailable for other processes. In this situation, if we take only one resource is currently being allocated for a process, this comes under a condition of low resource utilization. So each resource can be individually allocated for a separate process, which prevents the process from getting into an starvation state. This is the conclusion of the exclusion of hold and wait condition. Then the third one is no preemption. In this, if a process that is holding some resources requests another process that can't be immediately allocated to it, then all the resources which are currently held by that process should be released immediately, and the preempted resources are added to a list of resources for which the process are waiting. So from the list, the process which can be requesting for that release resource can utilize it. And further, for allocating of that resources, the process will be restarted only when it regains all the old resources which was held by it, as well as the new resources that is requested has been allocated to this. In the situation, the wastage of time and the resource which is stagnating on a single process will be avoided. And the final solution is circular wait. To impose a total ordering of all the resource type, it requires each process request and resource in an increasing order of enumeration. That is nothing but, if we go in this order, the previous circular wait condition we have seen, the last process Pn is depending on the resource which was held by a process P0. In this situation, the order is getting lower. But if the system is designed in a constraint, it must depend on the higher order of the process, then this formation of cycle will be avoided. If the formation of cycle is getting avoided, then the system is in safe state. These are the 4 methods of prevention of deadlock, and these are the examples for deadlock prevention.